Hi, Algebra 2. I'm going to go over the help board questions. Hopefully this is all recording. Yeah, it looks like it is. Okay, so let's just start real quick. Go through them rather quickly today because I got a late start on this. A lot of things were happening. So we're going to do, the first one is this one, Shannon's A. So I need to get a color that will show up. Black won't work. Okay, so it's long division problem. We're dividing 2x plus 4y. We're dividing it into 8x cubed plus 64y cubed. Now we need to leave little holders here. So it's 8x cubed. Now the x's go down, the y's come up. Remember the song? The x's go down and the y's come up. So we need to place holders. So we're going to put the 0. The x's are going to come down to x squared. The y's are going to come up. Then we're going to have 0x x y squared. And then finally we're going to have the one that they gave us, which was 64y cubed. Okay, so we're going to begin our long division like we have done from Algebra 1. What times 2x will give us 8x cubed? It's going to be 4x squared. We multiply the 4x squared times the binomial that's outside of the division bar. So we're going to get 8x cubed plus 16x squared y. And we change our signs and we add, so we get negative 16x squared y plus 0xy squared. So then we're going to take it times negative 8xy and distribute that through. So we get negative 16x squared y. These have to match up exactly. And then we distribute that through. So we get negative 32xy squared. And we do the same thing. We change our signs. We add. We get 32xy squared. Bring down the 64y cubed. And this would go in 16. And we already have the x, so it'd be y squared times. So we distribute that through. We get 32xy squared plus 64y cubed. And we change our sign and we add and we get 0. And so this is your final answer. Ta-da! Okay, the next one we have is number 3. Some of these I'm just going to set up for you rather quickly. This is one of our favorites. It's a distance problem. So we have 2 different distances. So we need 2 different little roads here. So one is 720 miles. So that's the distance of Donna is 720. And the distance of Mabel is 200 miles. All right, now we read along with the problem. Remember, distance is rate times distance. Rate Donna, time Donna, rate, who is this? Rate Maple, not Mabel, time Maple. So we set up our equations. RD TD equals 720, and our other one is RM TM equals 200. We have a couple more pieces of information. It says that Donna took twice as long. So the time of Donna was twice as long as the time of Maple. Here. Time of Maple. And the other equation that we have is the rate of Donna is 40 more than the rate of Maple. So we have those equations. Now, you'll notice that I have both of these solved in terms of the D, so that we can plug them into this equation up here. So RD is equal to RM plus 40, and TD is equal to 2TM. And that's going to equal 720. And we distribute this through, we're going to get 2RM TM, and you'll notice that's right up here, plus 80 TM equals 720. So we're going to take this RM TM, it's equal to 200, so we're going to put that in right there. So we get 2 times 200 plus 80 T sub M equals 720. And we just do our little rearranging and all that, and we can solve it from there. So you can just take it from there, right? So you're going to get 400 plus 80 TM equals 720, et cetera, to subtract the 400, divide by 80, and you have it. Okay, so that's 3. Let's do number 5. Number 5 is David and Levan found 3 consecutive multiples of 11 such that 4 times the sum of the first and the third was 66 less than 11 times the second. What were the numbers? Okay, so this one we haven't done very many of these, but if if they're multiple of 11, the first one is going to be 11x. That's going to be the first one. Just think if x was 1, the first one would be 1 times 11, which would be 21. The next one would be 2. If it's going to be the second one, would be 22, right? So it's going to be x plus 1 would give us our 22. That's our second. And then it's going to be 11 times x plus 2. If it said consecutive, even or odd, I don't know if it would even say that. You would add 2 and 4. So this is our third. So that's our first setup. So I just thought this through a little bit. I thought, well, if it's 22, the next one will be 44. So instead of taking it times 1, I take it times 1 plus 1. So the setup is the tricky part. Once you get the setup, it's not so bad. So it is 4 times the sum of the first and the third. So that we just look over here. So it's 11x plus the third would be 11x plus, I just distributed that through, is equal to, and I'm not going to finish solving this even though I did on my paper, but I think you can take it from there. So it's going to be 10 times, let's see, 10 times the second, 66 less than 10 times the second. So the second will be 11x plus 11, we distributed that through, minus 60. And then you can solve it from there. So what I got was x equals 2. So the first one would be 22. The second one would be 33, and then 44. So there you go. All right, that was number 5. Number 7 is a little geometry thingy. So let's get this one going here. So we have this triangle with a circle in the middle of it. Like that, and then we had a circle in the middle. I don't know if I can do this or not. Let's see what I can do. Okay, you know, something like that. Not quite what I was hoping, but we're gonna go with it. So we will just put we had 15 here, and y plus 3 here, x down here, y plus 8 here. The thing you have to know is that x plus 15. This is kind of important that it touches up here. So, okay, let's just make a little more of a circle here. So it's going to touch these points. Now, tangent lines to a circle are going to be congruent. So what that means is this is going to equal this equals this, and this little thing equals that little thing. So we're going to start out with this one. We can say 15 equals y plus 3, and we get y equals 12. And then we can just plug them in here. This side's going to be 12 plus 8, so it's going to be 20. And then this x is going to equal 5 because this is also going to be 20. 5 plus 15 is 20. They want you to also to find the perimeter. So we would have to, this would be 15, right? We know that. And we would know that x is 5. So it'd be 5 and 5. So we would add 15 plus 5 plus 5 plus 20 plus 5 plus 15. And we get an answer of 80. So the perimeter is going to equal 80, and it doesn't have units, so we don't need to write units. All right, that was 7. Number 13. 13 is use substitution to solve. These are like slight nightmares because they just have fractions all over the place. They're just trying to help you to learn to manipulate equations. So you pick a variable to solve for. Obviously, elimination would have been super duper easy, but I'm going to pick this. It's the smallest number. I'm going to solve this equation for x. So 2x, I'm solving it in terms of x and y, in terms of y. So we're going to get x equals 3 halves, y minus 5 halves. Then you're going to take what x is equal to, you're going to put it into the other equation where the x is. So you get 4 times 3 halves y minus 5 halves plus 3y equals 17. So 2 goes into 4 2 times 3 is 6y. 2 goes into 4 2 times 5 is -5 plus 3y equals 17. And we get 9y equals 27 and y equals 3. And then you just put your 3 back in here and you're going to get x equals 2. A little messy, but they're just trying to teach you how to manipulate equations in different ways. All right, 13, we are now on number 20, or did I do 9? Did I do 9 yet? Let's see, what is 9? No, I didn't. I skipped one. Okay, so let's do 9. 9 is y equals x squared plus 4x plus 6. And you're supposed to use completing the squares and aid in graphing. Okay, if you ask these questions, like a lot of people ask the same questions, like trying to figure out what's going on here. So to complete the square, this is not a perfect square, so we're going to bump him out and get a replacement guy. The whole goal is to put this in vertex form, which is going to be something that you need to know for later. So vertex form is a parabola or quadratic equation that's in the form y equals a x minus h quantity squared plus k, where h and k are the vertex of a parabola. If the a is positive, it's going to be a happy parabola. If the a is negative, it's going to be a sad parabola. So we have a happy parabola here. So we're going to have x, we have to complete the square first. So we divide the 4 by 2, and we get 2, and we square it, we get 4. Whatever we added, we need to subtract off. So it's going to be 4. This is a perfect square trinomial, which always factors into something quantity squared. So this is going to be x plus 2 quantity squared. Add these together, we get 2. Now we can identify the vertex of the parabola. That was the whole point of putting it in this form. So the vertex is always the opposite of whatever's in the parenthesis, which so would be -2, and then this number, which would just be 2. So when we graph it, we graph the vertex, which would be -2, 2. And then you can use, this is something really important, don't tune me out yet. This number right here is the y-intercept. Think about it. If you put x in, 0 in for x, that's the y-intercept. So your y-intercept is going to be at 6. Parabolas are symmetric around this axis of symmetry. So we went over 2 up 6. We're going to go over 2 up 6. And you can construct your parabola. I like those problems. Okay, so we did 9. Was 13 the one that I did? The next one would be number 20. Number 20 is quite the messy little thing. So m over m squared plus m over m squared plus 1 over m. So we're going to start at the very bottom right here, and we're going to find the common denominator. The denominator of the denominator. So we're going to get m over, hopefully I have enough room for this, m squared plus m over, and then the common denominator is m. So it's going to be m cubed plus 1. I took m times this one doesn't need an m, and then I'm going to flip the bottom over. So we're going to get m squared, I'm just going to do a little flip-de-doo, plus m squared over m cubed plus 1. Very messy. Now I'm going to take everything times the denominator of this denominator. So in the numerator, we're going to get m times m cubed plus 1. I'm going to multiply everything by this m cubed plus 1. Now I'm going to take m squared times m cubed plus 1. And we're going to get m squared here. Distribute everything through. M to the 4th. Just making sure I don't make any mistakes. I did this problem somewhere. The worst when you get halfway through these problems and you realize that you made a mistake. As you guys probably have done yourselves. Except I can't find where I did it. Oh, here we go. Okay. So we're going to get m to the 4th plus m And then in the denominator, we're going to get m to the 5th. Add your exponents when you multiply, m squared plus m squared. We can take an m out of everybody because there's an m here and m. So let's do that. So if I take an m out of here, I'm going to get m cubed plus 1. Down here, this is going to be 2m, right, squared. So if I take an m out of that one, I'm going to get m to the 4th plus just 2m. And then we just cross these m's out, and this is our final answer. You have to be really careful on those. They're tricky. Okay, 25. Oh, you know what? I didn't do this one, but I'll do this one for you. I can at least get it set up. 25. These are our friends, peeps. Okay, so yeah, they didn't start out being friendly, but I think they're getting friendlier, right? So this vector is 4 up this way. So if it's 4, it's not going left or right, so it's going to be 0 right plus 4 up. Now we have a vector down in this quadrant, which makes it tricky. This is probably why you got the wrong answer. So this is your x, this is your y. Remember this? So we say x equals, and the angle in there is 29. So x equals 6 cosine 29 degrees, and y equals 6 sine 29 degrees. So we pop those into our calculator, and I didn't do this ahead of time, so I'm going to do that now. 6 times cosine of 29. Now here's the tricky part. These are both going to be negative. They're going down and to the left. So whatever we get for our answer, we need to make it negative. So I got positive 5.247, so I'm going to write negative 5.25. And the same, whatever I get here, I'm going to make negative. So it's 6 sine of 29 degrees is negative 2.91. And so this is your up, this is your right, and that's your up. So you're going to add this, negative 5.25 right minus 2.91 up, and just add those up, and that should be your answer. Okay, 29. 29 is one of these, negative 16. Chad is saying he never gets these right. So let's figure out what you do wrong. I think I could kind of tell you what that is in a second. Negative 3 minus I to the 5th. Okay, so first of all, the square root of 16 is 4, but it's imaginary, so it's going to be 4i. Now, you need to pop your i's out of these. So I know that sounds terrible, but we're going to get square root of 2i, square root of 2, square root of 3i, square root of 3i, and then this is the same as I squared times I times I. That gives you 5, right? If you add your exponents up. This is going to be negative 1, this is negative 1, so that's going to be positive. So it's not going to change your sign any. It's just going to be negative still, and we're left with 1i, so it's going to be I. All right, now, tricky stuff coming up. All right, square root of 2 times the square root of 2 is going to be 2. I'm just going to leave these i's for later. All right, so that's going to be 2. The square root of 3 times the square root of 3 is going to be 3. And then we have I. So it's going to be I cubed minus I. Now, I squared is negative 1. So it's going to make this whole thing positive. 2 times 3 is 6, and we still have an I left over. So this is I squared times I. I squared is negative 1, which makes this positive, minus I. And then all we have are i's. So it's going to be 10 minus 1, and the answer is 9i. It's just all about being careful and making sure you pop your i's out. You don't want to multiply these together and get 9. Then you wouldn't have any i's. So pop your i's out first, and then do your radicals. All right, lesson 104. Lesson 104, we don't have any practice problems to do. We have number 2. Let me look at it. I think I decided not to do all the word problems. Yes, we're not doing, this is the distance problem, same as the previous lesson. I already did that. Okay, number 4. Okay, I actually did this one. This is a boat in a river problem. These are kind of cool, if you can kind of think of them as cool instead of hard. So you have to know your two equations for this one. So this is number 4. You have distance downstream equals the boat. Look, the water's going with it, so you're going to add the rate of the water. This is the rate of the boat, the rate of the water. Downstream, the water's pushing down, and we have the time downstream. Distance upstream is the boat, but now the water is pushing against and making it slower. So we're going to subtract off the rate of the water, and then it's the time upstream. All right. So we have those. It's 168 miles downstream. We don't know the boat or the water, but we know the time is 12. Distance upstream, we have that distance. We know that it is 54. And we don't know the boat or the water. And the time is 9. We're going to, one thing you can do, you can either distribute it through and then divide by 12, but this is all divisible by 12. So I'm going to divide this by 12. And we're going to get 14 equals a little trick. If you can do that, look, this one works the same. We're going to divide it by 6. So 9, and it's going to be 6, right? So we're going to get 6 boat minus water. Look how nicely this works out. So we're going to get 20 equals 2 times b, and we're going to get b equals 10. B, it looks like a 13. B equals 10 miles per hour. Yay. Okay. Hope that helped you. We are on number 8. Number 8 is find the area of the equilateral triangle whose sides are 4 times the square root of 3. Now this one, here we go. Equilateral triangle, there's probably more than one way to do this. I'm going to put an altitude in it because to find the area you need the height. True, right? So we have the side is 4 root 3. So we know that this little triangle is 2 root 3. So I just did the Pythagorean theorem. This is going to be a 30, 60, 90 triangle if you want to work from that, but I'm just more comfortable with Pythagorean theorem. So 2 root 3 squared plus h squared equals 4 root 3 squared. And so this is going to be 4 times 3 plus h squared equals 16 times 3. And that's going to give us 12 plus h squared equals 48. H squared is going to equal 36, and h equals 6. So the height is 6. So to find the area of the triangle, the base is 4 root 3. So it's 4 root 3 times 6 divided by 2, which is 24 root 3 divided by 2, which was going to be 12 root 3. And it's going to be centimeters squared. Alrighty, so that's that one. Let's see, that was 8, right? So let's go to 12. 12 is complete the square. I'm doing this one, even though I did one like it, because of the negative sign, which causes some trouble. All right, so we have to take out the negative. You can't have a coefficient when you complete the square. I know, very unfortunate, isn't it? So we're only going to take it out of these two. So it's going to be negative 4x. We're going to get a replacement guy, and we're going to have negative 2. You have to keep it all balanced. So we're going to divide this by 2 and square it. Again, we get 4. But instead of subtracting off the 4 that we added, do you see how this is really going to be a negative 4? So we have to add on a 4. It's very tricky. So you're going to do the opposite sign when we have to factor out a negative, or it's actually going to be the same sign. So we get y equals negative. It's not a happy parabola because it's negative. And the vertex, this is really similar to the last one, so I'm not going to finish this, is going to be 2, 2. And the y-intercept, if we did do this one, the y-intercept is going to be negative 2, right? The vertex is 2, 2. It's opposite. Make sure you do the opposite for that one. And it's going to be, it's symmetrical, so it'll be 1 over here. And we just go like this, and there we go. That's our parabola. Number 12. All right, next one is 16. 16 is, let's see, did we do 16? I didn't do that one. Okay, 16 is solve. All right, I didn't do this one either. So we'll do it on the fly here. All right, so you can do it a couple different ways. I'm going to solve this one for y at the top. So it's going to be 4x minus 2 equals y. And then I'm going to plug it in. So for y, so we have x equals 4x minus 2 equals 3. So I'm taking this and putting it where the y is. And we get 4x squared minus 2x minus 3 equals 0. I'm setting equals 0 because it is, it's quadratic with the 2. So you set it equals 0. I'm going to attempt to factor it. Ooh, I don't know about this. 2x and 2x. If I put a 3 here, I'm going to get 6 minus 2. That doesn't work. So that doesn't work. So yeah, even I have to, when I'm factoring, try different things out. I don't think this is going to factor. So if it doesn't factor, you're going to have to use the quadratic formula, which is really kind of unfortunate right now. So we would put this in. I'm just going to look at the answer and see if they did use the quadratic formula for number 16. Yes, it takes it's a quadratic formula, so you have to put it in there. So x equals negative b, so it's 2 plus or minus the square root of b squared, which is 4, minus 4 times negative 3 all over 2a. 2 times 4. I'm going to let you guys finish that. That's how you would do the problem. I mean, this is kind of a long problem. After you get your answers, you have to go put it back up here and get y. So yeah, a little tricky. I mean, I guess I can go a little bit further. X equals 2 plus or minus the square root of 4. And that's going to be, I'm going to use my calculator, 16 times 3 is 48. So 48 plus 4 is 52. I'll just double check myself. 4 minus 4 times negative 3 is 52. All right, so it needs to be simplified even. How about that? 4 goes into 52 13 times, so we're going to get 2, and then it's going to be plus or minus 2 root 13 all over 8. And then we're going to cross all the 2's out, so we're going to get x equals, it's still a fraction though, so it's going to be 1/4 plus or minus root 13 over 4. Then you have to put it back up in here, which isn't very nice, is it now? And so you're going to put it in here, so it's going to be 4 times 1/4 plus or minus the square root of 13 over 4 minus 2 equals y. So we're going to get 1 plus or minus the square root of 13 minus 2 equals y. And so y equals negative 1 plus or minus the square root of 13. So sorry about that, but that's how it goes. It's a tough one. Okay, and the last one in this lesson is number 30. So use unit multipliers. Oh, where did this one come from? Okay, I didn't prepare that one, so I'm not going to do that one. If we want to do that in class tomorrow, I'll do it in class. Okay, just trying to work through these rather quickly. Okay, lesson 105. We have A, B, oh boy, 105. Okay, solve by factoring. First thing you have to do on these, this is lesson 105A. First thing you have to do is put them in order. So it's going to be 2x squared minus 5x minus 12 equals 0. And then you have to factor it. You guys were saying this is hard. So what times what gives you 2x squared? 2x times x. What times what gives you 12? Well, we could do a couple things. We could do 1 times 12, 3 times 4, or 2 times 6. And I can tell you right now, it's not 2 times 6 because you can't put a multiple of 2 in this parenthesis. And these are both multiples of 2. So we're going to go with 3 and 4. You really just have to experiment. I'm going to put the 4 there, the 3 there. I kind of thought it out in my head. This is 8 and this is 5, and that does give you a negative 5. So it's going to be negative 8, positive 3. So once you factor it, you have to set each of the factors equal to 0. And you're going to get 2x equals -3, x equals -3 halves, and x equals 4. And that's how you do that kind of problem. B is similar, so let's do B real quick because these are the new problems. I don't mind doing new problems. So we're going to get, let's put everything to the left, 3x squared minus 7x minus 6 equals 0. Factor it, and we get 3x and x. Now, they're different things. You could do 1 times 6 or 2 times 3. If you do 2 times 3, you cannot put the 3 in with this 3. So I'm going to put the 2 over here, the 3 over here, and hope for the best, or 1. It's going to be 1. I don't know where I got that. Oh, never mind. This is a 3, and this is a 2. Okay, your outer is 9, your inner is 2, and that gives you 7. You need it to be negative, so you need to make the 9 negative, equals 0. So we're going to get x equals -3 halves, x equals 3. Check, check. Okay, so we got our B's done. Let's go to number 3. Adrian, you must hate word problems, right? Okay. I did not do this one, or did I? Yes, no, I didn't, but I'll set it up for you. So number 3 is in a flask was 140 milliliters of a 20% solution. How much should be added? So we don't know that, of a pure alcohol. This is the tricky part. It's 100% is going to equal a final solution 44%, and it's going to look like this. So this is one variable, so you're going to use one equation. So you're just going to take 20 times 140, 100 times x, and 44 times x plus 140. And you just multiply that out and solve it, and you get your answer. That's the setup, though. All right. The next one is 5. All right, so I'm going to skip that one too. We can take care of that in class tomorrow if you want. 7, skipping that one. 9. I haven't done these, have I? Okay, let me do a 9 real quick. 0.01651. I'm just going to, I will just set this up for you. So you can see there's 3 places after, so we're going to need 3 zeros. So we're going to take 100, 1,000 times, we're going to call this as n. We're going to take 1,000 times n, which means we're going to move the decimal point over 3 places. You have to do it as many places as are covered. So it's going to be 16123.51 minus n, which is going to be, now we're going to do we have to put a couple more 6 5-1s there. Sorry, my family's talking. It's hard to concentrate. 651. So we're going to do 0.01651, and you can see how it lines up then. So we're just going to subtract these, and then we're going to get 999n equals, and then you subtract it and divide both sides by 999. All right. Okay, 9, and then the next one is 17. Did I do 7? Okay, we skipped that one. 17. I don't know why. I kind of missed all these problems when I was doing these myself. 17 is a circle with a line going through it, so it's x squared plus y squared equals 8. X minus y equals 2. This is one you can't do elimination, so you're going to have to solve it for one of the variables. So I'm going to get y plus 2. We're going to take this and put it in here for x. So we get y plus 2 squared plus y squared equals 8. You do the mature way of foiling it. Okay, equals 8, and then we get, we're gonna have to use the quadratic formula again, 2y squared plus 4y minus 4 equals 0. I think I did that right, did I? Yep, these add together, 4y minus 4 equals 0. I would divide everything by 2 here. And I don't think it's factorable. No, so you would put this in the quadratic formula, guys, I'm sorry, but that's what you have to do. And then you have to add 2 to your answer. So that is the brunt of that. All right, what should I do? I'm going all out of order. I'm crazy here. 21. 21 is just like the ones that I did. It's the, I'll do this one, it's a little bit different. 3x cubed minus 5x squared minus 2x equals 0. You have to pull out an x here. See, it's common. So you're going to get 3x squared minus 5x minus 2 equals 0. And then you're going to factor after that. So these are the new problems. So 3x and x, 2 and 1. I would just pop the 2 here, the 1 here. You have to check your outer and inner. Make sure you get the middle. So your outer is 6x. So it needs to be negative. This is this one. So you're going to get 3 solutions. So you're going to get x equals negative 1/3, x equals 2. And so those are the 3 solutions for that one. 21, did I do 19? Yes, I did. Okay, as much as no, I didn't do 19. 19 is the same as what we did in the beginning. Oh no, 19. So almost done here. 19 is a 3x plus 5y equals 4. I'm just going to set this one up to 10x minus 15y equals negative 50. Guys, you can just use, just multiply this by by 3. And so you're going to get 9x plus 15y equals 12. 10x minus 15y equals negative 50. And then you eliminate. This is these old kind. 9x equals 38, x equals 2. Plug that back in and get y. All right, lesson 106. I'm just moving along here today. 106, I'm only going to do number 18. I think that's the only one down there, so let's do that. Lesson 106, 18. So solve by graphing. I thought this was different, so that's why I'm doing it. And y is greater than negative 2. In order to graph, you need to solve it. So you get negative 4y equals negative 3x plus 8. Y equals 3/4 x minus 2, because you're dividing everything by that negative 4. So it was an absolute value, it was an inequality problem. We divided by a negative, so it's going to switch. So this switches the inequality. So when you plot these, I'm going to plot them really quickly. So we're going to get the first one is y equals negative 2. So you're going to get is greater than negative 2. And it's a dotted line because it's greater, it's not and equal to. So you would shade all up here like this. All right, then the next one is, I better switch colors. It's going to be bad if I don't. So let's just do negative 2. So it's going to be down here. It's the same place. That's your y-intercept. I think that's positive. So we're going to go up 1, 2, 3, 4. No, rise 3, 1, 2, 3, and run 4. 1, 2, 3, 4. It's right here. This is not a dotted line. It's a, not a dotted line. So it's going to go like this down here. And we are going to put arrows on the end. And this one is less than, so it's going to be under here. So where do they overlap? Well, the overlapping part is right this area. So that's your solution, is where it overlaps. All these points in here make both of these inequalities true. Okay, so that is it. Any other questions we will deal with tomorrow.